We'll get to the science, and then it will be showtime. So here we go. There we go, we got it.
7, 6, 5, 4, 3, 2, 1.
Now, let's talk a little bit about science to start the show. What is matter? There we go. I can't see behind my head. What is matter? Can anyone see matter in this room? You're made of matter, exactly. You are all made of matter. I am made of matter. The air we breathe is matter. And all this matter is made of these little tiny particles called what? Atoms, right. Can I show you a single atom? No. No, we cannot see a single atom, but we can talk about how they work. So if we heat up these atoms or give them energy, much like the green things on the sphere, they're going to spread further and further and further and further apart. If we cool them down, they come closer and closer and closer. Now, 3 states of matter that we'll be experiencing during the show. Actually, 4 states of matter: solid, liquid, gases, and plasma. Yes. So we will be seeing these 4 states during the show. But the next important part, right here,
2, 1.
how can we change matter? Okay, so 2 ways we can change matter. This is a match. Watch closely. Wow. Is it still a match? Yes, I just made it a little bit shorter. That was a physical change. We've changed what it looked like, but we haven't changed what it was on a molecular level, right? It is still has the same parts that make it a match. So we might be doing physical changes throughout the show by changing matter from a gas to a liquid to a solid. It's still the same matter, we just brought the atoms closer, further apart. But a chemical change is the next way we'll change matter. There we go. So, combustion. 3 things come together. Fuel, the stick, heat, which I got from friction, and oxygen in the air to help keep this thing burning. So those 3 ingredients will come together for combustion to make some new things and release energy throughout the show. It is time for the first demonstration. Fireball. Okay, cool. Interesting one to start off with. So Fireball is using this stuff called lycopodium powder. Lycopodium powder is extremely flammable, okay? So if I take a little bit of this lycopodium and I put it in my hand and bring it right here, I'm gonna go close to you since you're my fire safety team. Okay, here we go. Nothing happens. All right, so we've already talked about combustion. While this is a very flammable thing, we can notice that it's a very fine powder. If we want this to burn, we're gonna have to get enough oxygen to each one of those tiny particles, okay? So I'm gonna grab this tube and move it over here, put it right here. All right, we're going to put the lycopodium into this cap, and then we're going to dump it all onto a very hot candle, okay? All right, so let's get our candle, light that on fire, put that right here. There we go. Put the tube on top.
8, 7, 6, 5, 4, 3, 2, 1.
Hot air balloon. All right, so for this one, we need to heat up some air. Now, we cannot see the air heating up. The atoms that make up that air are really hot or really far apart. So to show you what's going on here, we need a balloon. Now, this balloon is full of air, and I heard some people say they've seen it before. If you've seen it before, it's okay. You don't have to stay here. It's fine. All right, so for this one, what we're doing is we're heating up the air in the inside. You notice that the balloon is inflating. Are we adding a lot of air to it? No, we're not pumping air into it. We're getting that air hot. As the air gets hot, the atoms spread apart. Now, that means it's less dense than the air on the outside. So if we let go of the balloon, where does it go? Exactly.
6, 5.
We call this convection. It's a fun bit of weather science, okay? So next thing we have to do here is the fire sprays. Okay, so for fire sprays, we're going to, oh gotcha, there we go. All right, so fire sprays, we need some special elements over here, okay? So we have something called copper, something called lithium, and something called, here we go, potassium, okay? So these 3 things are not actual potassium, copper, metals, melted. They are metal salts mixed in with some fuel. Now, regular fire is going to look like orange and red. But if you add certain elements to this fuel, things like lithium nitrates. You get to see more pink fire. Potassium gives you a little bit more of a purplish. And copper is more of a green. So if you like fireworks, it's mixing these elements. All right, excellent. Next one we have balloon pop. All right, balloon pop. All right, my least favorite one here. Here we go. This one we're finally gonna work with that really cold stuff, liquid nitrogen, okay? So liquid nitrogen is the liquid form of the gas that makes up most of the air we breathe. If you get it down below -320 degrees Fahrenheit, it turns into a liquid. Here we go. But here is the liquid form. Since it cannot stay that cold, it's going to return to its gas form, taking up 700 times its space that it did as a liquid, which means this balloon will have to grow to 700 times its size to contain all that gas. Not exactly safe. This is definitely where you want to pay attention to our sign, okay? Here we go. 2, 1. You're right, it's not gonna pop in time. We can't control when that happens, which means I have to move on to the next one and wait for this thing to explode. Whoosh bottle. Okay, so I'm gonna try to stay away from that. All right, so for a whoosh bottle, we need 5-gallon water jug here. There we go. Oh, get away from me. Okay. We're gonna add, let's go for copper. Let's add a little bit of copper. So I'm gonna add 3 sprays of copper to this thing, okay? I can't count. That's why I need you to do the counting for me. All right, so for this one, we've added our fuel to the bottle. We next need to add our source of heat, because we already have oxygen in the air and in that bottle. All right, let's see, where are my matches? There they are. Okay, so we drop a match in here. We're gonna heat up the air on the inside, start that fuel burning, spread it apart. There we go. Cork pop. Okay, cork pop. Now we're going back to our liquid nitrogen. We saw what happened to the balloon. It's a good thing we didn't get that one right after the balloon one, because we're gonna need that thing. Okay, so we saw what happened. Nitrogen cannot stay in its liquid form for very long. It's gonna boil, return to its gas form once it reaches anything above -320. So, if we try to contain that, it becomes extremely dangerous. These corks are going to become dangerous projectiles. There we go. Let me try aiming for a light. There we go. Oops. There we go. Oh. How much time do we have? 7 seconds? All right, rockets.
Yeah.
Okay. Now a rocket, that's going to require combustion again. So let's move to our rocket platform. All right. So for a rocket ship, we get to see what happened with our whoosh bottle already. We caused an explosion inside of the whoosh bottle. We saw how all that heat, all that air, all the fire came rushing out through the top, right? So for this one, we're going to flip the whole experiment upside down. Now, third law of motion, for every action, there's an equal and opposite reaction. We've already talked about this briefly. But for this one, we're going to add our fuel to the bottle here, cause an explosion on the inside. Everything's going to come rushing out through here and push it in the opposite direction, okay? So, here we go. Adding our fuel.
7, 6, 5, 4, 3, 2, 1.
Cloud, there we go. Cloud. All right. You can leave whenever you want. You don't have to stay and watch me, okay? All right, but for those who do want to stay and see the end of the show, what we're going to talk about next is a cloud. If we heat up this water, you're going to see some steam, okay? Water vapor, we have little droplets of water rising into the air, becoming water vapor. Once that reaches our atmosphere, it condenses, and what do we see floating up there high in the sky? Clouds. So this is how we form our clouds. Now, to cheat a little bit, instead of having to rise all this water high up into the air, we're going to throw some really cold stuff on it. And luckily, I have that liquid nitrogen already ready to go. So, let's mix it together.
8, 7, 6, 5, 4, 3, 2, 1.
All right, there we go. All right, next one we have is wild card. All right, so the wild card round was kind of designed to like give me a break. So we're gonna do a, I'm gonna call it the pose for photos round, where I just take a break and pose for photos. Okay. It actually feels nice. Okay. All right. Science can be noisy. Wow.
7,
How much time do we have? That was a long minute. Okay.
3, 2, 1.
All right. Next one, and the last one too, is balloon shrink. Okay. So balloon shrink means I'm going to try to fit as many balloons into this can as possible. Now, liquid nitrogen. We saw how it condensed the water vapor into that cloud. If I put a bunch of balloons full of air into this can, they're going to condense as they get colder. So let's get our balloons and see how many we can fit in the time that we have left. All right, here we go. There's 1, 2. All right, come on. Here we go.
Oh, wow.
14 seconds, thank you, Ari. Here we go. All right.
10, 9, 7, 6, 5, 4.
I'll take it.
Yeah.
That's good enough. And we did it.
Yeah.
So, and I think I survived. So, totally out of breath. So, that was the 10 and 10 show, and I think we were successful. So if anybody has any questions, feel free to hang out, come on down and say hi. Otherwise, thank you so much for witnessing that crazy thing. Have a wonderful day at the museum. Enjoy the rest of your day. We'll see you around, guys.